This is Physics Lab number 4, Oscillations. The goal of this experiment was to compare the predicted motion of a glow script code with the observed motion of a real experiment of a mass attached to a spring that was moving. We were to plot the change in position of predicted motion and observed motion, as well as plot the change in energies from the predicted motion. The change in kinetic energy, change in potential energy, change in spring potential energy, and change in total energy were all found on a graph. So the overall results were that the change in total energy was 0, and the predicted model and observed model are relatively similar in terms of positions in the y direction. Physics concepts include Newton's second law. So the net force equation is change in momentum over the change in time, velocity update, which is derived using the net force equation, and a position update, which is derived using the velocity update equation. We also use the energy principle, which is the change in energy of a system is equal to the work done on the system by the surroundings and the exchange in thermal energy between the system and the surroundings, as shown here in this equation. Energy is neither created or destroyed and can be transferred from one form to another. The total change in energy in the system is equal to the change in kinetic energy, change in gravitational potential energy, and change in spring potential energy, which is what we saw in this experiment. The system was the weight, earth, and the spring, and the surroundings were nothing. So since there was nothing in the surroundings, nothing from the surroundings can do work on the system, and the total change in energy of the system is 0. We can also look at a free body diagram of the system, which only includes the force of the spring and the force of gravity. The force of the spring and the force of gravity are equal and opposite, so net force equals 0. Here is what the tracker data looked like. I set the calibration stick to 0.7 meters because that was the length of the string with the spring with the mass on it, as stated in the pre-lecture video. The origin is set at the base of the spring, and the tracker data began when this object is released from the hand. The mass of the weight attached to the spring was 0.402 kilograms, as stated in the pre-lecture video, and the initial conditions are as follows, which was taken directly from the tracker data. The spring constant is also used from the video, and the relaxed length of the spring also from the pre-lecture video. Here are the GlowScript equations. So these equations were all mentioned before, and they were inputted into GlowScript as follows. Same for all of these equations. So velocity update, position update, spring, and all the energies were once again used for this part. So here is a video of the GlowScript running. Here's all of the code, and I already went through it in the previous slides. And when the code is run, this is what it looks like. The ball is oscillating, and you can see the change in energy graph. So here are what the position graphs looked like. They weren't shown in the video, but here are the position graphs, and here was the change in energy versus time graph again. Some possible errors from this experiment could be that the initial velocity was assumed to be 0 meters per second, but the absolute value of the initial velocity could have been slightly greater than 0. So it could have been in the negative x direction or the negative y direction. Other forces, such as drag force, were also not accounted for in this experiment. So, what does it mean? For your model system, is the energy principle satisfied? Justify your answer by discussing briefly your plots of energy changes. So, yes, the energy principle is satisfied. The change in gravitational potential energy and change in spring potential energy are opposite of each other, and the kinetic energy oscillates, as shown in this graph. The total change in energy is consistently 0, which is the orange line, which means that the energy principle is satisfied. The sum of kinetic energy, gravitational potential energy, and spring potential energy are the total change in energy, which is 0. So, using the data you obtained in Tracker, make 2 separate estimates of oscillation periods. So, my estimate for the first oscillation period was approximately 1.519 seconds in the x direction, and for the y position, it was approximately 1.33 seconds. So the difference in oscillation periods could be due to things like drag force or slightly incorrect tracking of the center of mass. So just a couple of concluding remarks. Other forces that were taken into account could be the reason for slight differences in condition data between the experimental data and the GlowScript model, and it was easiest to not include anything in the surroundings for the simplicity of energy calculations.